Hi everyone, it's Ben again. This video is going to be a continuation of the last video where we set up our Oculus Touch controllers in Unity. Last time we got the position tracking and the rotation tracking working. So if you haven't seen that video, I would recommend you check it out before we get started with this one. This time we're going to look into setting the buttons up, and we're also going to create a script which lets us pick objects up and throw them about and stuff. So it should be pretty fun. So first thing we want to do is set up the buttons. Let's have a look at our touch controller script that we wrote last time first. So you can see that last time we used this OVRInput class to get the controller position and the rotation. Now you could use the OVRInput class to get all of the button information as well, but that's not actually necessary because Windows already detects all of the buttons that the Oculus Touch controllers have, or at least most of them. And we can use those button names in the Unity input manager. So let's go to our input manager here. And if you've not used the input manager before, this is how you set up all of your buttons. You can give them unique names so that you can call them in your scripts. So I've already gone through and figured out which buttons are which on the controllers, and I've actually mapped out to an image that I've got here. So you can either pause the video or you can, I'll put a link to the image in the description. But this basically tells you all of the names of the buttons and the axes so that you can set them up in Unity. So the buttons that we want to use today to actually grab things are the 12th axis, which is it's called the right hand trigger, and the 11th axis, which is the left hand trigger. So let's try and remember that. We'll duplicate this element. We'll call it L hand trigger, and we will set gravity to 0, dead zone, that's fine, sensitivity is 1, let's make it 1.5, just so that when we've got it held down, we definitely know we've got it held down. You can play with this later on. We don't want to invert it. We do want it to be a joystick axis, and the axis was the 11th axis. So let's duplicate this one, and we'll call this R hand trigger. Same settings as before, except this time it's the 12th axis. Now, if you look at Fire 1, we can see Fire 1, see this has already been set up. These ones are set up by default. Fire 1 is already joystick button 0, which is the A button. So if you press, if in a script you say Fire 1, that will get triggered whenever you press the A button. And that's the reason why these Oculus Touch controllers will work with other games, because the axes and the buttons they're named with standard names. So we've got these set up. Now let's create a script. I'm going to call this grab, and you can set up other buttons using that image as well if you like, but today we're just going to have the triggers, the hand triggers. Cool. Let's make that a bit bigger. We don't need the start method. So let's just make sure that these are actually working. So we're going to say if input.getAxis R hand trigger. We will make it so that this works with both triggers, but for now we'll just say R hand trigger is equal to 1, which means that we're squeezing it all the way down. We're going to say debug.log time. So that should come up in the debugger every time for every single frame we've got this squeezed all the way down. That should give us, so we just want to test that this trigger is actually working. Right hand, grab on here, we'll remove this. So let's play and see what happens. There we go. So you can see down in the corner here, every time I squeeze the button, it tells us the number of seconds that have passed since we started playing. So that's cool. So the right hand trigger is working. Cool. Right, back to here. So we don't want to say this. Instead, we want to call a grab method, grab object instead, and we will write this up here, void grab object, and then we're going to say for the opposite, if it's less than 1, we want to drop the object. And let's write that as well, void drop object. And we're going to want to know what that object is, so let's put a private game object. We're going to say grabbed object, so we'll store whatever object we're grabbing up here. Also, at the moment, every time of every single frame, if the trigger is held all the way down, it's going to call this method, and we don't want that to happen. We only want it to happen once. So we also want to have a boolean private bool grabbing to tell if we're already grabbing something, and if we are already grabbing something, then don't call the grab object method. So we're going to say grabbing equals true whenever this is called, and then grabbing equals false whenever the drop's called, and then we're just going to add those into here. So we're going to say if you're not grabbing and the trigger is squeezed, then grab the object, and if you are grabbing and the trigger is released, then drop the object. So that should, there's the logic there, so that should work. Get rid of that. Okay, so how are we actually going to grab our object? There are a few ways you can do this. I think you can do it with triggers and stuff, but I'm going to use a sphere cast. So if you're unfamiliar with sphere casting or ray casting, I would recommend you look up some tutorials. But in the most basic terms, a sphere cast is you shoot out an imaginary sphere from a certain location in a certain direction, and any colliders that are within that sphere are going to get returned as an object of type raycast hit. So we're actually going to use a sphere cast all, which is slightly different. But as I say, if you want to look into sphere casting and ray casting, go ahead, because they're pretty cool. Raycast hit, we're going to make this an array. I'm going to call this hits. And this is going to be, this is what the sphere cast is going to return. It's going to return an array of hits. So we're going to say hits equals physics dot sphere cast all. Now, sphere cast is going to want some parameters to work properly. So first thing we want is the position of the sphere cast, and we want that to be on the player's fist. So we're going to, and this script is attached to the hand, so we're just going to say transform dot position. Then it's going to want to know the radius of the sphere, and it would be cool if we could choose that ourselves. So let's say grab radius, and then we'll put that up here, public float grab radius. Cool. Next one is the direction. So the way the sphere cast works is that you shoot a sphere out in a certain direction along a certain path. We don't want to do that. We just want the sphere to appear wherever our fist is. So the direction doesn't actually matter. Transform dot forward, why not? And then the next one is the length of the ray, which again doesn't matter because we just want it to appear. So we're just going to say 0. And then the last one is a layer mask. So the layer mask basically means that if we decide to put a layer mask in here, we don't need to put a layer mask, we could just end it there. But if we do put a layer mask, then the sphere cast will only register colliders that are on a specific layer. And we do want that to happen. So we're going to make a new layer mask, and we call that grab mask. Let's put that up here. Public layer mask grab mask. And then we'll choose that later on. Okay, so that's our hits array. Now, if we call this grab objects method and there are no hits, then this hits array will be of 0 length. And if it's of 0 length, there are no hits, we don't want to do anything. So we want to check that. We want to say if hits.length is greater than 0, then it means we have hit something. And then we're going to put our let's grab the object code in here. If it's not, then nothing's going to happen. So what we're going to want to do is we're going to loop through our hits array and we're going to check whichever one is closest. So it's unlikely that you're going to detect more than one object when you want to grab something, but if that does happen, you want to grab the closest one. So we're going to say for, and then that sets that up, and we're going to say hits.length. Okay. And we're going to want to track the index position of the whichever object is closest. So we're just going to create an integer up here. We're going to say closest hit. For now, that will be 0. So we want to say if hits, the hit that we're looking at the moment, if the distance, and the distance is the distance from the center of the sphere to wherever that collider was. So if that distance is greater than the closest hit index dot distance, then the closest hit becomes I. Hang on a minute. If the distance is less than, that makes more sense. Okay, cool. So now we know that the closest hit hits closest hit. We know that this is the object that we want to grab because the sphere cast has checked all of the colliders that are within the radius of the sphere. It's returned them to the array, and we've just gone through the array and figured out which of those items is closest to the center of the sphere. So we know that it's this one. So let's store that in our grabbed object variable up here. So we're going to say grabbed object equals hits.closestHit.transform.game object. Okay, so we've stored the objects that we're grabbing. Now, when we grab an object, at the moment, all of the objects that we're grabbing they have rigid bodies attached to them. And when we grab an object, we don't want that object to be affected by forces anymore because we want the object to follow our fist. So the way that you can make a rigid body not to be affected by forces is by making it kinematic. And if we go back to Unity, let's actually create something to grab, shall we? 3D object cube 0.1. Let's make it a stick 0.5, 0.1, and then we'll 0 this. So this is what we're going to grab. We're going to add a rigid body. We can see we've got this is kinematic. So when this is checked, then it's no longer the rigid body is no longer affected by forces, but we're going to want it to be unchecked at the moment, and we want it to be affected by gravity. So let's we're going to call this stick, and we're also going to want to have some kind of like a table or something for it to rest on. Let's 0 this. There we go. Okay, right, now everything's white. Let's make some new materials. Oh yeah, I've already created these materials previously. We've got a material for our hands. right hand, left hand, and then we've got a material for the stick material, and we might as well create, let's just duplicate this, we'll call it table mat, and we'll make this kind of grey, and we'll call this our table. And while we're here, we also wanted to put this stick on a grabbable layer, because that sphere cast is only going to affect objects that are on the grabbable layer. So let's add a layer, and we'll call it grabbable. Cool. Let's go back to here and set it grabbable. Where's this script? Grab. Wait, did I save? I don't think I saved. Let's save this. Will this compile and show me the grab? Yes, there we go. So grab mask, we're going to set it to grabbable. Cool. And then we'll set the radius of the sphere to 0.1. Oh, okay, let's go back. So we explained before that this when we grab the item, we want to make it kinematic so that it's no longer affected by forces, so that it just follows our hand. So and we can do that from the code. So we can say grabbed object dot get component rigid body 90 dot is kinematic equals true. And then we want to move that object to the position of our hand, so we can say grabbed object dot transform dot position equals transform dot position. And then we want to basically lock the grabbed object to our fist. Now, you can do this a couple of ways, but the easiest way, I mean, this might get complicated later on, but the easiest way for now is just to say grabbed object dot transform dot parent equals transform. Okay. So that will mean that whenever you move your hand and whenever you rotate it or move it through space, the grabbed object will just be locked to it, because you're going to set the grabbed object as a child of your hand. So let's save this, and hopefully that will allow us to pick an object up. So let's have a look. Okay, that's a bit out of whack there. Hang on. Table, we'll move this down a bit. And then maybe move this forward a bit. Let's have a look. Okay, let's move the left hand up the way. Right, I'm going to squeeze the trigger. There we go. Cool. Now, when I let go of the trigger, nothing happens because we haven't created that method yet. But there we go. I've grabbed it. Now let's fix this thing. So when the object's a bit too close to the camera, it starts getting eaten away there, and that's because of the clipping planes. So hang on. Main camera. So the clipping plane is 0.3, which is 30 centimeters. So anything that's closer than 30 centimeters to the helmet isn't going to get rendered. So if we set that to 0.1, then that will fix that. So it will only not render anything that's closer than 1 centimeter, and that's not going to be an issue. Right, so let's drop. So dropping is actually slightly more complicated. First of all, we want to check that we actually have a grabbed object. If we don't have a grabbed object, then we don't want to do anything. So we'll say if grabbed object does not equal null, then we're going to execute our grabbed object code. So first thing we do, we want to undo everything that we've just done here. So we're going to say the parent is going to be null. And we're going to do that is kinematic. Is kinematic is false. And we're also going to want to set our grabbed object variable to null, so that we can pick something else up later on. Okay, let's see if this works. Let's go back to Unity. Right, grabbed it, and then I release the trigger, and then it drops. Cool. Let's do that again. Nice one. Now, we could stop there. However, what if we want to throw it? So let's give that a go. I'm gonna toss it over here, and then I'm gonna let go of the trigger, and we'll see what happens. Right. So so nothing happens. It just kind of falls straight away. And that's because when we're grabbing it, this object is kinematic, so it doesn't have any forces applied to it anymore. So the minute we let go and we turn is kinematic off, then its forces are all set to 0, and it just kind of starts off from the assumption that it's just kind of come into being and it's just going to drop because of the gravity. And if it had no gravity, then it would just stay there in space. So what we want to do is, when we drop the object, we want to apply some forces to it, and we can get those forces from our hand. So let's pause this and come back to here. So we're going to get the rigid body again, and we're going to apply a force. Or no, we're not going to apply a force. Instead, we're just going to change the velocity. Say the velocity is equal to, and then we're going to use the OVRInput again. So we're going to say that the velocity of the rigid body is going to be equal to the velocity of whatever our hand was. So we're going to say get local controller velocity, and then let's do what we did before, controller, and up here we're going to say public OVRInput.controller. Cool. And while we're at it, let's say public string button name. And then down here, instead of saying our hand trigger, we're just going to say button name. And then that will mean that we can set this script up for both the right hand and the left hand. Button name. Cool. Hang on, we didn't finish this. Controller. No. Yeah. Okay. So that's the that should apply the velocity of the controller to the object when we drop it. So let's go back to Unity. Now we'll have to set up the script again. Controller or touch, button name or hand trigger, and then while we're at it, let's go back to our script and then put it on the left hand as well. Controller L touch, button name L hand trigger, which is what we set up earlier. Grab radius can be the same, and then the grab mask is grabbable as before. And also, why not duplicate some of these? So we've got a few different sticks to play around with. Okay, let's see. There we go. Right. So now let's try throwing. Way, awesome. And the left one works as well. And we can drop things around and grab and push stuff around. Cool. So we're nearly done. The last part, unfortunately, is a little bit confusing. Or it took me a while to figure it out anyway. Let's stop this. So, actually, no, let's play a game. And we'll see the dilemma. So, while we can throw things, what you'll find is that if you kind of try and spin something, it doesn't spin properly. Let's see if we can catch it. Yeah. But yeah, if you try and spin something, it won't spin. It just kind of stops and then goes with the regular velocity. So we want to add an angular velocity as well. Now, unfortunately, the OVRInput class does have. It does have. Let's just say this. Let's copy it. Now we could say angular velocity equals OVRInput dot get local controller angular velocity. And this does actually exist. Get local controller angular velocity does actually exist. But in OVRInput, get local controller angular velocity, we can see is, if we hover over it again, we can see that it's of the type quaternion. But the angular velocity here is a vector 3. Now, maybe someone out there can figure out how to convert a quaternion to a vector 3. I looked into it. I'm not that smart. I couldn't figure it out. So instead of doing it this way, instead we're going to track the position of our hand, and then we're just going to calculate the angular velocity that way. So let's delete that for now, and we're going to create. How are we going to do this? We're going to create a couple of rotations up here. We're going to say private rotation and current rotation. So we're going to track the last rotation of the hand and the current rotation of the hand. And then in the update, we're going to say if we're grabbing something, if grabbed object does not equal null, last rotation equals current rotation, and then current rotation equals grabbed object dot transform dot rotation. So this is basically just going to track the rotation in the last frame and the rotation in the current frame. And then when we drop the object, we're going to use those two rotations to calculate the angular velocity and then apply that to the rigid body. It's the long way around of doing it, but it's the only way that I could figure out how to do it. So, and I've actually copied the code from somewhere else. So we're going to want to get the angular velocity. We're just going to create a new method down here that returns a vector 3. I'm going to call it get angular velocity. And then rather than type it out, I'm actually just going to grab it. I've already got it in a notepad thing over here. Hopefully this works. It doesn't work. That's because monodevelop is kind of rubbish sometimes. Let's reload this. Let's zoom back in again. There we go. So here's the code. If you want to type it out, let me just, you can pause the video. But this is how we're gonna determine the angular velocity using the current rotation and the last rotation. We're going to return the angular velocity using this equation here. So let me just scroll through so that you can see what that is. If you want to pause and type that out, you can. And then we're just going to say the angular velocity is get angular velocity. Okay, so hopefully that should calculate the angular velocity using the previous position of the object and the current position, and then apply that to the rigid body. So we've saved that. Let's return to Unity and play. Oh no, hang on. get angular velocity. I didn't do that correctly. There we go. It's because it's a method. Let's play. Right, now hopefully if we spin, there we go, it adds the angular velocity as well. So there we go, I hope that helps. So we could amend this so that, because at the moment it's just grabbing the object at the center, basically the pivot point of wherever that object is, the center of the transform. You could do it so that you could apply different points to the grabbable object so that you can grab it at different points. That could be something. You could do it so that it snaps into a position. So let's say you want to grab a gun. You don't necessarily want to pick it up at whatever angle that you've kind of grabbed it from, which is what's happening at the moment. So you might want to snap it to a particular position so that when you hold a gun, you can then point it. And so on. But you know, the possibilities are endless, and just messing around with this kind of stuff is pretty fun, to be honest. Yeah, so I hope that helped. Yeah, catch you next time. Bye.